Hello everyone. In this video we're going to be solving an exponential equation with ln x and e to the power x minus 1. So this is a very exponential equation, but we've done a similar problem before. I hope you'll remember that, and I can try to link that down below here. We have x to the power 1 over ln x equals e to the power x minus 1. So I'm going to present two approaches and then also show you a graph. So let's go ahead and start with the first method. For my first method, I'm going to do the following. Since I have 1 over ln x as an exponent, it makes sense to raise both sides to the power ln x so we can get rid of the 1 over ln x. So here's what I do. X to the power 1 over ln x raised to the power ln x, and I do the same thing on the right hand side. Great. Now when you multiply the exponents, ln x cancels out, leaving us with x to the first power, which is the same thing as x. And on the right hand side, we get something more complicated. But don't worry, we're going to distribute it and simplify it. Since ln x is going to be multiplied by x minus 1, I can go ahead and distribute it and write this as e to the power x ln x minus ln x. Now the subtraction of exponents just indicates that this is division. So I can write this as x equals e to the power x ln x divided by e to the power ln x. Because when you divide powers, you subtract the exponents. If the exponents were subtracted, that means division. All right? So properties of exponents obviously are very, very important. Now, we got some nice things here. What is it? It is e to the power ln x, which is at the bottom. And that means something. By definition, e to the power ln x is the same thing as x. Of course, we want x to be positive, needless to say, in order for this to be well defined. Now, what am I going to do with e to the power x ln x though? I don't have that x e to the power ln x directly. But don't worry, we can go ahead and simplify this. We can write this as e to the power ln x to the power x, since the exponents have been multiplied, and the bottom one just as is. Now, remembering that e to the power ln x is equal to x, this becomes x equals x to the power x divided by x. Great. So why don't we just go ahead and cross multiply, noting that x does not equal 0, because we know that by definition or by domain, we know x is greater than 0. So x cannot be 0. We're good. Let's go ahead and cross multiply. We get x to the power x is equal to x squared. And that should give you the very obvious solution, x equals 2 from here, right? But that's not the only possible solution of this equation, because when you have x at the base, that means 1 can also work. And we see that x equals 1 works for this equation at least. How about negative 1? Well, let's go ahead and test it out. Negative 1 to the power negative 1 is negative 1, but negative 1 squared does not equal negative 1. So these two are not equal. Therefore, x equals negative 1 is not the solution. But we had to check that. So it looks like I got two solutions, and my domain said x is greater than 0, right? So everything looks good, except for the fact that at the very beginning, in our original equation, we had 1 over ln x. Now, if x is equal to 1, then 1 over ln x becomes undefined, because ln x becomes 0, right? And this becomes undefined. Therefore, we can't take x equals 1, which means we only have one solution, x equals 2 from here. Obviously, that's the first method. We're still going to take a look at the second method and also check the graph. All right, let's go ahead and take a look at the second method. Let me rewrite the equation so you get to see the original problem. I got x to the power 1 over ln x equals e to the power x minus 1. And I'm going to be solving for x values. A lot of times with these equations, especially if you have ln x in the equation, no doubt about it, definitely do it. But in any case, pretty much, we ln both sides. Especially the presence of e on the right-hand side gives us a good clue. And 1 over ln x obviously is going to cancel out. Just like with the first method, but in a different way. So let's go ahead and ln both sides. If you do get the following, ln x to the power 1 over ln x equals ln e to the power x minus 1. Now here's a couple things we need to do. If you have ln b to the power n, then you can write it as n times ln b. Or of course, in this case, you have to be careful about the domain. If b to the power n is positive, but b is not positive, then we have a problem. So we have to be using the absolute value. That's why a lot of times people are just going to use the absolute value symbol to guarantee that b is, or the absolute value of b is always non-negative. Anyways, we know x needs to be positive. Did I say that with the first method? I think we're good. 1 over ln x is also going to be positive. Well, I shouldn't say that, because in order for ln x to be positive, x needs to be greater than 1. And we're going to see what happens. Anyways, I'm just going to go ahead and move this forward. That gives me 1 over ln x times ln x equals x minus 1 times ln e. But ln e is just equal to 1, so I don't even need to write it. So we can safely say that ln e to the power m is always m, because m is going to be moved and ln e is always 1. Great. Now here, just like before, ln x cancels out, and that leaves us with 1 on the left-hand side, which means x minus 1 is equal to 1, and that means x is equal to 2. Now we didn't get x equals 1 here. Why? Because we did not use the first method. Okay, I don't know if that's a valid explanation, but with the first method, yes, we got an extraneous solution somewhat. But in this case, we only got one solution, and you can easily check, you can just go ahead and substitute that into the original equation, which I'm going to do, and verify that it is indeed a solution. Let's go ahead and do that right now first, and then we're going to look at the graph. So x to the power 1 over ln x equals e to the power x minus 1. If I plug in x equals 2 on the left-hand side, I get 2 to the power 1 over ln 2. And on the right-hand side, I get e to the power 1, which is e. Great. So how can I show that this equals e? Well, here's one thing you can do. You can call this 2 to the power 1 over ln 2. You can call that z. And then you can just ln both sides. And if you ln both sides, ln 2 to the power 1 over ln 2 is equal to ln z. Excuse me. And then you can move the 1 over ln t here. 1 over ln 2, I mean. 1 over ln 2 times ln 2, which is 1, equals ln z. From here we get ln z equals 1, which means z is equal to e, which means this is equal to e. And we also got e from the right hand side. This is e, so we are good. Okay, let's go ahead and take a look at the graph now and see what happens at the graphical level. So I graph both of these functions, but wait a minute. Why is the orange graph a straight line, a horizontal line? Because this is a constant for x is greater than 0. That's why our graph does not work for negative values in 0. It only works for positive values. So our only solution is going to be, in this case, x equals 2. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.